So now I'll be solving the fifth question of Codeforces round 787. In this question, we are given a string and we need to form the lexicographically smallest string by performing k operations. So in one operation, what we can do is we can select all the occurrences of a particular character and reduce it by 1. So if we have a number of C's in our string, then it will convert to B. If we have Z, A, then it will convert to Z. So of course we need to find the minimum lexicographical string. So such an operation is not viable. That is, we will never convert A to Z. So what we can do is that if we have more than k, if we have all characters which can be converted into A in less than k steps, that is, if we take the first test case, we can convert C to A in 2 steps, B to A in 1 step. So what we'll do is we'll first convert C to B, and then we'll convert both the B's to A in 1 step. So our output will be AAA. That is something like this. So it is CAB. Then what we'll do is we'll convert it into BBA. Then we can convert both B's to A in one step itself. So it will become AAA. In the next test case, we have FGDE. We have FGDE. So what we'll do is we'll first, and we have five operations which we can perform. Maximum operation is 5. So we can convert F to A in F minus A steps, which is 5 steps. In 5 steps we can convert F to A. Okay, so but we cannot convert G to A in 5 or less steps. So first we'll convert F to A. We'll convert F to A. Then we can in this process both D and E will also convert to A in this fashion. Say first, in the first step we'll have EGDE. In the next step we'll have DGDD. Both the E's will be converted to D. Then we'll have CGCC, then BGCC, BGBB, then AGAA. So we have performed all the 5 steps and we get this as our output. So G cannot be converted into any further any smaller character. If we initially try to convert G, then we will not get the lexicographically smallest string because G can be converted minimum to B. So our output will be something like BBBB, which is not lexicographically smallest. So now I'll take the last test case. So the last test case is 4 and 19. We have E, K, V and Y. So as we see, E and K can be converted into A in less than 19 steps, but Y cannot be converted into A in less than 19 steps because Y takes 24 steps to be converted into A. So what we'll do is first we'll try to convert E and K to A. So for this, the best possible way is to try to convert K to A. Subsequently, E will automatically be converted to A. So converting K to A takes 10 steps. Okay, so we will have, after 10 steps we'll have something like this. After 10 steps, so now we will try, we cannot make Y and V both A. So what we'll do is reducing Y is the best possible thing that we can do. Subsequently we will automatically become small. So we have 9 more steps. So after after 9 steps, y will be converted to p and v will also be converted to p subsequently, automatically. Okay. So through observation we find that if there is any character in the string that requires more than k steps to be converted to a, the conversion will stop there, which means that first e will be converted, then k will be converted, then y will be converted, and conversion will stop there because subsequent characters we don't have any extra steps to convert them. So we will maintain a map which stores the corresponding character for each alphabet after conversion. For example, here for k we'll have a, for e we'll have a, and for y we will have p and we'll store it. Only these three are converted. V is also not converted, but we'll see what we'll do with it further. So after we store the converted character for each of the alphabets, now we'll loop through the string, and for each character, smallest character corresponding to any alphabet after conversion will be considered. For example, if we see for v, we'll take all the subsequent characters, which is for w, x, y, z, for all the characters, we'll see which is the smallest corresponding converted character. So for y we have p, so for v also we'll have p as our output. So in this manner we can form our output. So if we see the fourth test case, we have 19 steps, but y cannot be converted to a. So what we'll do is we can convert e to a and k to a. Then for y we have 9 extra steps. So in 9 steps we can convert y to p, and for each of the corresponding characters we'll find the subsequent converted character, smallest subsequent converted character. So I'll code it. It is a bit complex, but I'll try to explain you with the code. So we'll take the test cases. We can form a map of char type. Initially we can store the corresponding character, the same character at that position. So mp of ch will be equals to ch. Now we'll loop through the string. Now if s of I minus a, which is the number of steps which we need to convert the current character to a, is less than equals to k, then we'll make mp of s of I equals to a. Also we'll store the current biggest character. For that we'll take a character and we'll store the maximum character until now. Now if we don't have the required number of steps with us, which is we need to take k in our input. So basically if we cannot convert the current character to a in the required number of steps, then we'll do something like this. So what we'll do is we'll make k equals to 0. Initially what we'll do is we'll make count the number of steps we extra steps that we have. So it will be k minus biggest character minus a, this thing, this is this thing. So number of extra steps that we have is x. So now we'll make mp of s of I is equals to s of I is equals to s of I minus x and we'll break out of the loop. Now we'll form the corresponding string. We'll try to find the smallest character for the current character. We'll loop from s of I to z and find the smallest character. And we'll print the smallest character for each. I'll try to test the code on the sample cases. Okay, so probably I have not taken the string as input. Okay, so we're getting the right answers on the sample cases, so I'll submit the code. The code is accepted.